There we go. All right, starting off our trig section in geometry. First thing I want you to do is go ahead and underline, circle, star something. Okay, that's going to be pretty important to us. It's pronounced SOHCAHTOA. Okay, SOHCAHTOA. That is going to help us with trig. So there are three basic trig functions. It's sine, cosine, and tangent. Okay, this SOHCAHTOA is going to help us create the trig ratios. What does ratio mean to you? If I tell you to write a ratio, what is that? It's a fraction. Okay, so these trig ratios are fractions. I want to start with basics first. Go ahead and circle this. That's called theta. Okay, that's just a reference angle. Okay, that is just an angle. So far this chapter, we've talked about how to find missing sides of right triangles. Do you agree with that? Okay, what was the first method we learned? Pythagorean theorem. Okay, what did you need to know to use Pythagorean theorem? Right, in order to use that, how many sides did you have to know? 32. You had to know at least 2 to find the missing side. Okay, what was the next part we learned after Pythagorean theorem? To find missing sides. Right, we did the special right triangles next. How did we know when we could use those? Based off of the angles, right? If it was 45, 45, 90, or 30, 60, 90. Now I'm going to ask you this. What would you do if we didn't have a special right triangle and we didn't know 2 of the sides? It is not a no solution. That is when this trig comes in. Okay, so right now, this theta, this angle, represents any angle that's not 45, 45, or 30, 60. Okay, it represents any angle. I want to label sides first. So label with me. This reference angle, what is this side called right here? Hypotenuse. That's never going to change. Yep, label that side. That's your hypotenuse. Okay. Now, in regards to this theta, this side is going to be opposite. Okay, so label that side opposite because you go across the triangle. Okay, and then what is the geometric term where you say right next to? Think way back. It is adjacent. Yep, so that other leg is the adjacent leg. Now, I understand that hypotenuse is also adjacent to that angle. Do you agree? Okay, but we always want to call that side the hypotenuse. Okay, so no matter where theta's at, hypotenuse is always going to be the same because it's always across from that right angle. What if I put theta here? What if I put theta there? The opposite and adjacent are going to end up switching sides. Does that make sense? Okay, so all of these sides are based off wherever theta is or wherever that angle is. Okay, so let's talk about the trig ratios with sine, cosine, and tangent. Okay, this is an acronym to help you out. Okay, so the S here stands for sine. Okay, so sine is opposite over hypotenuse. Okay, so write that. Sine is opposite over hypotenuse. Okay. Cosine is the C. Cosine is A over H. What do you think that stands for? Adjacent over hypotenuse. And then tangent is this T is OA. That's opposite over adjacent. Are you seeing the connection between the acronym and the ratios? Yeah. Okay, so S stands for what? Sine, and its ratio is opposite over hypotenuse. C stands for cosine, and it's adjacent over hypotenuse. T stands for tangent, and it's opposite over adjacent. Okay, that acronym is supposed to help you in remembering SOHCAHTOA. Okay, just to give us some practice, label your sides. Let's label opposite A, adjacent B, and hypotenuse C. Let's make some connections here. Again, in relation to that reference angle there, what is my opposite? What's my opposite side? A over hypotenuse, C. That's my trig ratio. Okay, what about cosine? What's adjacent? B, hypotenuse is C. And then tangent, what's opposite? A, and adjacent is B. Okay, again, biggest thing is knowing where your reference angle is. Okay, so I'm gonna skip over this box for now. Jump down to finding each ratio. Okay, so I'm looking here. On this left column, okay, what I want you to understand with trig is the letter with the trig, that is the angle. Okay, so just label one of these. That's the angle they're talking about. Okay, so right now we're talking about angle K. Okay, so our reference angle right now, what they're talking about is K. So I want you to circle K in the diagram. Okay, so sine of K. What was the ratio for sine? Opposite over hypotenuse. What is opposite of K? Sides, yep. What's opposite of K? 24. And then what's the hypotenuse? 26. With these ratios, you always want to simplify. So we always want to reduce these. What can I reduce 24 and 26 by? What can I divide both those by? 2 to get 12 over 13. What about cosine of K? What's cosine's ratio? Adjacent over hypotenuse. What's adjacent to K? 10. What's the hypotenuse? 26. Is the hypotenuse ever going to change? No. What can I divide both these by? 2 to get 5 over 13. Hey, what about tangent of K? What's tangent's ratio?
24 over 10.
Opposite over adjacent, which is 24 over 10. What can I divide both those by? 2 to get 12 over 5. And you can leave these in improper fractions. Okay, you can leave them as improper fractions. Yes, this is a coincidence. You will not always divide by 2. Okay, that's just a coincidence. You're going to reduce them the same way you've always been reducing since junior high. Okay? All right. When I get to this column over here, what's different? I'm going from M now. Again, what does this M mean? That's the angle. So go ahead and circle your angle. If you need to erase the one on K, go ahead and do that. Okay. So sine of M, what's sine's ratio? Opposite over hypotenuse. What's opposite of M? 10. Yep, and remember we're talking about side lengths now. What's the hypotenuse? 26. Divide both those by 2, you get 5 over 13. What do you notice between the two signs? Are they the same or are they different? The hypotenuse is always going to stay the same, but is the sine ratio always going to be the same? Yeah, it just depends where. Yes, you're correct. That's what I meant. The sine ratio and cosine and tangent depends on where the reference angle is at. Okay, sine of M is not going to be the same thing as sine of K. Okay, what about cosine of M? What's cosine's ratio? Adjacent over hypotenuse. What's adjacent to M? 24. Yep, and the hypotenuse? 26. Divide both those by 2, you get 12 over 13. And last one, what's tangent's ratio? Opposite over adjacent. In this case, it's 10 over 24. Divide both those by 2, you get 5 over 12. Now I'm going to jump back up to steps for solving. Now we're actually going to be using these trig ratios to find missing sides. Okay, so I outlined some steps here for you so that you can go back to them if need be. Okay, so the first step we are going to do is we are going to label the sides. Okay, what I mean by label the sides, that you're going to label them opposite, adjacent, hypotenuse. Okay, step 2, you are going to identify the trig ratio. Okay, what I mean by that, you're going to pick between sine, cosine, and tangent based off of what sides you are given. Okay. Step 3, you are going to write the equation. Okay, and the equation is going to be in the form of, right now I'm just going to put trig, whatever trig you pick to the angle, and for the angle I'm going to represent that as theta. Okay, whatever trig you pick with the angle equals the ratio. Okay, and then step 4 is just to solve the equation. Okay, and spoiler alert, you are going to use cross multiplication. So let's take these steps and let's apply it to a problem here. So if I look at number 1, now what I want you to understand, I have this on the left outlined for you. Sooner or later, you're not going to have to do that side. Okay, I just have it outlined for you for practice. Okay. Even before the step 1, what I always want you to do is circle the reference angle. What's my reference angle in this picture? Angle. 36. Yep, it's going to be the angle that they give you that's not the right angle. Okay, so go ahead and label on the side. Our reference angle is 36. Okay, what was step 1 now? Label what? Label the sides. So what I mean, we look at our picture and look what they gave us. This 11.2, what is that? Opposite, adjacent, or hypotenuse? That's the hypotenuse, and you can abbreviate. What's x? That's adjacent in regards to this angle. Do we know what opposite is? No. So that's okay. We don't even need to label this side right now. So if I come over here and you want to label it, our hypotenuse is 11.2. Do I know what opposite is? No, I'm just going to leave it blank or put a line through it. And then adjacent is x. What was our step 2? Identify the trig ratio. What that means is look at the sides they give you. In this case, we have hypotenuse and adjacent. What trig ratio is adjacent and hypotenuse? Cosine. Yep, so our trig ratio we are picking is cosine. Okay. Once you have everything laid out, now we can write our equation. Okay, so we always start with the trig. So we pick cosine of what always goes with the trig? The theta, right? The angle. So what's our reference angle? 36. Cosine of 36 equals what goes on the right side of the equation? It's the ratio, right? What is the ratio for cosine? Adjacent over hypotenuse. So in this case, our adjacent is x. Our hypotenuse is 11.2. Now, I already spoiled it. We're doing cross multiplication. So you can treat this guy as over 1. Okay. What's going to end up happening between cosine of 36 and 11.2? You're going to end up multiplying, right? This is where your calculator comes in. So in your calculator, you got to be very careful about how you write or how you type this in. Okay. So type cosine of 36. If you type that in, you have to close the parentheses. Okay. So cosine of 36 times 11.2. You should get x equals 9.06. Number 2, always start by circling your reference angle for me. Then you know where you're going from. Okay, so in this case, our reference angle is 52. What do we want to do for our step 1 that I outlined for you? Label. What's x? X is opposite. Because remember, we're going across from that reference angle. What's 7.4? Hypotenuse, because it's across from that 90-degree angle. Good. So if you want to use this outline over here, our hypotenuse is 7.4. Opposite is x. I don't know what adjacent is. So what was our step 2? Identify the trig. What trig ratio uses hypotenuse and opposite? Sine. Okay. Now that you have it outlined, write your equation. Always start with the trig. What goes with the trig? What goes in the parentheses? The angle. Yep. Sine of 52 equals the ratio. What's the ratio? x over 7.4. Again, you can treat this as over 1. What are we going to end up doing with sine of 52 times, with 7.4? We're going to multiply them together. So sine of 52 times 7.4. Yes, you should get 5.8. I'm not going to be picky about how you round right now. Let's look at number 3. I'm going to show you that you don't have to fill this out if you don't want to. Okay? Always start with your reference angle. Circle it. What is it? 11. Cool. Label your sides. What's x? Opposite. What's 77.2? Adjacent. Do I care about the hypotenuse? No. Which trig ratio, bless you, which trig ratio uses opposite and adjacent? Tangent. Good. So we are picking tangent. Write your equation. This is where some of us get lost. What is always going to go with the trig? The angle. Angle is always going to go with the trig. Okay, so we have tangent of 11 equals, now it equals its ratio. What's tangent's ratio? Yep, it's opposite, which is x, over adjacent, which is 77.2. What do we do here? Yep, you multiply tangent of 11 times 77.2. Yes, you get 15 even. Which rounds up to 15. So, number 4, what's my reference angle? 43. Label your sides. What's 32.5? Opposite. What's x? Hypotenuse. Now, what do we do after that? Pick the trig, right? Which, Adam, you said trig is? Sine. So if I write my equation here, we have sine of what? 43. Sine of 43 equals? Careful. Yes, does it matter the order that you put the ratio? Yes, it needs to be in the order of what SOHCAHTOA is. So sine is opposite over hypotenuse, so it has to be 32.5 over x. Is this one as easy to solve as the others have been? No. Yes, you know how to cross multiply. I want to show you a little trick, okay, to save you some time. So normally we would do this, and it would turn into sine of 43x equals 32.5, right? Okay, how would I get x by itself here? I would divide by sine of 43. Now, is that going to be pretty annoying to do every time? Okay, do you want a trick? Okay, what I want you to think of this as, okay, is x, if x is on the bottom, those two are just going to end up swapping places. Okay, so x and sine of 43 are just going to swap places. Do you agree that's how they end up? Okay, so just think if x is on the bottom, they're just going to swap places. So type in your calculator 32.5 divided by sine of 43. So just to check yours, you should get 47.65. First thing, what's my reference angle on number 5? 65. How can I label x? Adjacent, 12.3. Opposite. Yep, remember that's in regards to that 65. What trig ratio uses adjacent and opposite? Tangent. Yep. So tangent of what? 65 equals. It's, yep, opposite over adjacent. Some of us were flipping it. Make sure we have it in the correct order. So 12.3 over x. Am I going to end up multiplying or dividing? Dividing, because x is on the bottom. Yep. So if I take 12.3 divided by tangent of 65, we get x equals 5.7. Okay. Number 6. Questions on number 5? All right, let's look at number 6. What's my reference angle? 22. What can I label x as? Hypotenuse. What about 24.6? Adjacent. What trig ratio? Cosine, because it's adjacent. And hypotenuse. So, cosine of what? 22 equals adjacent over hypotenuse. Am I going to end up multiplying or dividing? Why? because x is on the bottom. Yep. So we have x equals 26.5. Last one I want to do with you, number 7. Okay. Draw yourself a right triangle. Okay. It says an escalator has a vertical rise of 20 feet and created an angle with the ground of 11 degrees. What is the length of the escalator? Tell me some things I can label. Which angle is 11? It's the bottom one. Yep, because this is the ground. Okay. What else can I label? Right, the opposite is 20 because it said vertical rise. Okay, and then what am I looking for? Careful. What am I looking for? Right, the escalator is our hypotenuse. Okay, this adjacent leg here, that's the ground.
So are we supposed to picture the right triangle as an escalator?
Yeah. Yep. So now this is set up where we can use SOHCAHTOA, right? Okay, what is my reference angle?
11.
11's my reference angle. What can I label 20 as? Opposite. What about x? Hypotenuse. Which one is opposite over hypotenuse? Sine. So sine of what? 11 equals opposite over hypotenuse. Again, you can treat this as over 1. Are we going to end up multiplying or dividing? Dividing. So 20 divided by sine of 11. You should get x equals 104.8. Okay. Ways that I see where you get answers wrong. Okay. Listen, ways that I see where we're getting answers wrong. You have the work shown right, but we're using the wrong trig function. I've seen that. Okay. Or you're flipping your trig ratio. Those are the two main things where I see people getting the wrong answer. Okay, so make sure you're using the right trig ratio and the right trig function. Okay.